In this video, we're going to look at defining trigonometric functions of any angle. Up to this point, we've pretty much stuck with acute angles from 0 to 90. Excuse me. We're going to define a point on a terminal side. So in the little box here, definitions of trigonometric functions of any angle, we're going to let theta be an angle in standard position with xy as a point on the terminal side of theta, and r is going to represent the distance that point is from the origin. So remember, an angle in standard position, you have the initial side on the positive x-axis. A positive angle opens counterclockwise. Wherever it terminates, that point will be on the terminal side. When you have an xy coordinate in the plane, the distance from that point to the origin is r, and this is how you calculate it. The definition of sine is the y coordinate over the distance to the origin. Cosine is defined as the x coordinate over the distance the point is from the origin. And tangent is the y coordinate over the x coordinate. The other three are still reciprocals, so if you know sine, cosine, and tangent, flip them all over and you've got cosecant, secant, and cotangent. Let's do an example. Let's find the exact values of the 6 trigonometric functions of theta. Over here to the side, I have an xy plane, the y-axis, x-axis, and I have a point 3,4 on the terminal side. So we have an initial side on the x-axis. We open up theta degrees, and the point 3,4 is on the terminal side. The point 3,4 is 5 units from the origin. We use Pythagorean Theorem, and basically what you do is you go from the point given directly to the x-axis. The x-coordinate and y-coordinate give you the adjacent and opposite sides, and using Pythagorean Theorem, you can find the hypotenuse, which is the distance from the origin to the point. Now, once you've got that part, sine is the y-coordinate over the distance from the origin, so 4/5. Cosine is the x-coordinate over the distance from the origin, that's 3/5. And tangent is the y-coordinate divided by the x-coordinate, which is 4/3. Flip all three of these over, and you get your other 3 trigonometric functions. They're the reciprocals. All right, let's do another example. Very similar. We're going to take the point -8, 15. So we have an initial side on the positive x-axis. We open up, and inside here is where I'm going to call theta. The point -8, 15 will lie here. From the origin, we go left 8, up 15. The hypotenuse, or the distance that point is from the origin, can be found by Pythagorean Theorem. We use the square root of the x-coordinate squared plus the y-coordinate squared, all under a square root. And so it turns out the distance that this point, -8, 15, which is right here, the distance it is from the origin is 17 units. So x is -8, y is 15, and r is 17. Sine is y over r, that's 15/17. Cosine is the x-coordinate over r, -8 17ths. And tangent is the y-coordinate over the x-coordinate, -15/8. Flip all 3 over, and you have cosecant, secant, and cotangent respectively. The point 724 is on the terminal side of an angle in standard position. Find the exact value of the trigonometric functions of that angle. Now with this one, we don't have a diagram given with the point located in the XY plane, but that's okay. We know how to plot points, and that's what we'll do here, is we're going to draw in an X and a Y axis, and this is at the bottom right of your screen. The point 724, you go right 7 up 24. Your X coordinate 7, your Y coordinate is 24, and I've noted those here. The distance that point is from the origin. If you were to construct a right triangle, it is the square root of 7 squared plus 24 squared. This under the radical has a total of 625. Square root of 625 is 25. So this is our R value, and these are our X and Y values given from the point. Sine is Y over R. Cosine is X over R. Tangent is Y over X. Flip all three, then you get cosecant, secant, and cotangent. At the top of your screen, you see the reminder of the 6 trig definitions based on a point anywhere in the XY plane. This is the same from the first slide. This slide, the purpose is to help identify what quadrants sine, cosine, and tangent are positive and negative in. It really is based on X's and Y's. Sine, now R is always going to be positive because it's distance from the origin. Distance is positive. Now your X coordinate and Y coordinate can be positive or negative depending on where your point's located. So let's look at cases where we're given some clues and we're asked to determine a specific quadrant. Okay, so the upper left problem, we're given that sine theta is positive and cosine theta is negative. Sine is the Y coordinate divided by the distance, so it's all based on the sine of the Y coordinate. Y coordinates are positive in the upper two. Cosine is X over R. X, those are negative, less than 0, so cosine is negative in the left two quadrants. And where these two shadings, where pink and teal run into each other, is quad 2. Let's look at the top right of your screen. Tangent is Y divided by X. Y over X. In order for Y over X to be positive, either X and Y have to be positive or X and Y have to be negative, because a positive divided by a positive is positive. A negative divided by a negative is also positive. So in pink, this quadrant, quad 3, and quad 1 have positive tangent values. Cosine again is negative in the left two because X coordinates are negative in the left two quadrants. The overlap occurs in quad 3, and so that's our answer. The problem in the lower left of your screen, cosecant is positive because that's sine flipped over. Sine is also positive. Sine is dependent on the Y values or Y coordinates. Those are positive in the top two quadrants. Tangent is negative. Now let's think about that. Tangent is Y over X. In order for a fraction to be negative, only one of the two numbers can be negative. Well, where are the Y's negative? The Y's are negative in the bottom two, but you also have to have a positive X because a negative divided by a positive is negative overall. So we're looking for the two quadrants where the Y over X value is negative. In quad 4, X's are positive, Y's are negative, so they'll divide out to a negative value. And the same thing is true for quad 2. You have negative x's and positive y's. A positive divided by a negative is negative overall. Where these two quadrants overlap is quadrant 2. At the bottom right of your screen, cosine is positive where the x's are positive. Sine is negative where the y's are negative. The overlap occurs in quad 4. Let's find the exact values of the remaining trigonometric functions given that cosine is 12/13 and tangent is negative. From the previous slide, tangent's negative in quads 2 or 4. Cosine is positive excuse me, in 1 or 4. So that overlap occurs in quad 4. And again, that's where cosine is positive and tangent's negative. So what I do is I draw a segment into quad 4. Cosine is adjacent, or the x coordinate, over r, the distance from the origin. So I know that when I put, and let me label this real quick. I'm going to put my theta here. There we go. The x coordinate, 12. So we have to go x12, r13, 12, 13. Using Pythagorean Theorem, 12 squared plus the y-coordinate squared equals the distance from the origin squared. So if you solve it down, y squared equals 25. The square root of 25 is positive or negative 5. And because we have to be in quad 4, we choose the negative because y-coordinates have to be negative if we're in quad 4. Sine is y over r, so that's negative 5 over 13. Cosine was given, that's 12/13. Tangent is y over x, negative 5/12. Flip all three of these values over, and you get cosecant, secant, and cotangent. Find the exact values of the remaining trigonometric functions. This time we're given cosecant equals 4 and cotangent's negative. Because cotangent is the reciprocal of tangent, it will be negative the same quadrants tangent's negative in. Tangent is negative in quads 2 and 4 because your x and y coordinates differ by signs. And when you divide two numbers, one positive, one negative, your result's negative. Cosecant is the reciprocal of sine. 4 is the reciprocal of 1/4. So just looking at this value, we know sine has to be a 1/4. That gives us enough ammo to look and say, hey, our y coordinates have to be positive, but the ratio of y over x has to be negative. So that forces us into quad 2. And if we draw a little line segment into quad 2, sine is y over r. So our y coordinate has to be 1, positive 1. Our distance is always positive, that's a 4. And so using Pythagorean Theorem, we're missing the x value, so x squared plus 1 squared equals 4 squared. That gets us down to x squared equals 15. X equals positive or negative square root of 15. In quad 2, the x's are negative, so that's why we pick the negative, square root of 15. Sine is y over r. We were given cosecant. Cosine is x over r, negative square root of 15 over 4. Flip that over, you got secant. And tangent is y over x, 1 over negative square root of 15. Flip that over, and you've got cotangent. I hope this video has helped. Please feel free to reach out by email or phone if we're having class together. Please feel free to ask about any of this stuff in class.